Hello guys, welcome back to our channel. In the previous videos, we discussed about a encoder and the decoder. Today we are going to discuss about a 4:2 priority encoder. There is a difference between a normal encoder and a priority encoder. Let us say for an example, if you have a laptop and we are pressing the keys at a time, that means if we press the 1 and the 2 numbers at a time, then the computer has to choose the one number from the both of the two inputs, right? So further will be a priority comes into the picture. So in this priority encoder, how it works means it will take the highest possible, highest number will be taken into the consideration. Okay, let us see how this priority encoder will be work. So a 4:2 priority encoder means we will have a 4 inputs and we will have a 2 outputs. Let us say the 2 outputs will be y0 and y1. Okay, and the 4 inputs will be, let us say, d0, d1, d2 and d3. Now let us verify this. How I am saying this highest priority means, suppose if we have say that d0 will be have a lowest priority and d3 will be have highest priority. Okay, so that means when we come from up to bottom, there will be a priority change from d0 to d3. That means if you compare d0 with the d1, then if we compare both the d0 and the d1 will be the highest priority than the d0. Then irrespective of the d0 value, if the d1 is logic high, that means 1, then the d1 will be selected as the output. Okay, in this way the priority encoder will be work. Now let us see the truth table to understand this function more clear. So what can we do? What are the inputs are there? D3, D2, D1, D0, and what are the outputs? Y0 and the Y1, right? So if we have all the inputs are 0 0, then there will be no operation will be done. That means no key will be activated. So I am considering it as a don't care. Next, if d0 0 0 1, if d0 will be high, then the output will be 0 0. And if d2 will be high, irrespective of the d0 condition, that means the d0 will be don't care. In the d0 will be don't care means if it is the input is 0 or 1, it does not care about the d0 input and the output will be 0 1. If the d2 will be high, irrespective of the other inputs, the output will be d2 or 1 0. And if the d3 is high, then remaining will be don't care and the output will be 1. So this is the truth table. If you observe anything in this case, you can observe, if you observe this one here, the d2 have logic 1. So irrespective of the other inputs d1 and the d2, here there may be a 1 or 0, it does not care, the output will be 1 0. Now let us construct the k-map to get the expressions of the y0 and the y1. So here we require a truth table. Here I will consider d3 and d2, and here we will consider d1 and the d0. Okay, this is the truth table for the to get the expression for the y0. So if you observe this 0 0 0 0, if you have all the inputs are 0, then the output will be don't care, so x. So here you can observe 0 0 and the 0 1. So where we have get 0 0 0 1, then the output y0 will be 0, so 0 0 0 1 0. If you have 0 0 1 0, here the x may be logic 0 or logic 1. So let us consider this one, and the y0 will be 0. And here also 0 0 1 1. 0 0 1 1 means the output again will be 0. Here the d2 value is 1. That means here you can observe that if the D2 value is logic 1, irrespective of the other inputs, the output will be 1, right? So I am writing all this, okay? And here also the D2 is logic 1. So again writing yes. Here you observe that here the D3 is high. If you observe that if D3 is a irrespective of the other inputs, the output will be again 1. So 1 1 1 1. So now these 8 are one set and these 8 are one set, okay? Here you can observe that here what are the common things, this one and this one, right? So what is this? D3. So D3, and here in this second set what are the common, this 2 and the 3, this one is common, so D3 plus D2. In this way we can construct the expression for the y0. Now let us construct the expression for the y1, okay? So again we require another k map to get the expression of the y1. This will be the k map will be useful for get the expression of the y1. So again 0 0 0 0. What are the output for the 0 0 x, right? Here 0 0 0 1. So 0 0 0 1, the output will be y1 will be 0. So 0. So 0 0 1 1. Here the input D1 will be 1. So irrespective of the D0 input, the output will be again 1. So 1 and 1. Here you can observe that here again the D2 is logic I. So D2 is logic I. So irrespective of the other input, the output will be logic 0. So 0 0 0 0. And again here also same condition will be applied. And now here you can see that here the D3 is high, so irrespective of the all the inputs, the output will be 1. So 1 1 1 1. Okay. Now we will make, if you observe that here also you have the D3 in the place, you have 1. So here also you have 1. So if we have the 1, irrespective of the output will be 1, right? So I can consider here it has a don't care condition. So here maybe 1 or 0. So these can be one set, and here two ones are there, right? So these two ones and these two ones will be one set, okay? First, if you observe this for these ones first set, the what are the common things are there? D3, right? So D3, and in the these four ones, what are the common in this? 1 0 0 0. Here 0 is common, so D2 bar plus D2 bar. And what are the common at the upside? 1 is the common. So what is the ones? D1, right? So D1. So these are the expressions, y0 and the y1, these are the expressions to construct the 4:2 priority encoder. Now let us see how to make the Verilog code for this 4:2 priority encoder. Now let's do Verilog code for the priority encoder, 4:2 priority encoder. So I'm using the IDEA playground. So for that, this will be the data from modeling. So I am creating the module with the name called priority encoder, right? So pri encoder, and we require a input which is nothing but the four inputs, right? So 3 is to 0, 3 to 0 a, and our output will be two outputs will be there. So two output means 1 0, that means 0 and the 1, two outputs will be there. And y here 1, and I am ending this, and I will go on, I will assign the expressions in the we derived right using the truth table. So y0 is equal to a3 plus sorry, a means logical or a2. I'm closing this, and I'm again assigning the first bit, right? A of 1 equal to a3, or here there is a complement operation, right? A2, and with an operation a1. Okay. So these are the outputs and these expressions, and now I'm again ending this module. So this is the design code for our priority encoder. Now let's try the test bench to verify this. So module TV, what are the inputs? Register 3 is to 0 A, and the output 1 is to 0. There are only two outputs. So 1 is to 0 Y, and what is the name? We have to extract the inputs from the design code, right? So I encoder 1 for the input Y and the Y. Now let's start giving the testament initial begin and using the command to display the information in the console monitor. What are the inputs and the outputs? A equal to percentage B, comma Y equal to percentage B, A comma Y. Now let's start giving this. Here there are 4 bits, right? So 4B 0000 and 000. And I'm giving some time delay. Yes, I'm just copying this. Next here 011, here 0010, 0100, 100. Now let end this and module. Here I have to give the $finish command to finish the test bench. Okay, selecting the tools and the simulator. Yes, I'm saving this file and I'm going to run this. Yes, here I have to give the encoder. So I am giving the try encoder. I'm again saving this file and I am running this. As we have got the output. Here you can observe that for let us say this a equal to 0 double 1 double 0, right? So here the d2 a2 bit will be 1. So irrespective of the a1 and the a0 bit, the output will be 0 1, right? So let us verify this. Now I will give the 0 1 1. In this place I will give 0 triple 1. What the actual output we have to obtain 0 1. If it comes, then our code is perfectly working. So I am running this. Yes, we got the same. So if the A2 bit is logic 1, then irrespective of the other inputs, the output will be 1. So this is the Vela code for the 4:2 priority encoder. Thank you for watching this video.